Good afternoon, everyone. Welcome to our briefing looking at the economic and climate implications of methane emissions from the oil and gas sector. My name is Carol Werner, and I'm the director of the Environmental and Energy Study Institute. We are very glad that you're here for this discussion this afternoon. We think there are so many things that are going on with regard to methane, which is part of a group of short-lived climate pollutants that all of which are very, very important to address. But methane is another very troubling piece of this whole picture and is an area that I think is growing in attention across the country, which we think is very important that we all learn more about it. What can be done about it? Where is it coming from? What are solutions? And so that we just learn more from looking at the science through what this means in terms of ways to deal with it, in terms of the policy, the regulatory process, technology solutions, voluntary actions. And so we are very, very glad to have this panel to address a lot of these issues. And so we hope that you will see this as an important way to help make sure that we really get a powerful discussion going with regard to how we resolve issues around methane. Obviously, methane comes from a whole variety of sources, all of which need to be dealt with. Because methane has a large impact on climate, and an outsized impact on that, at the same time, it also means that addressing it means that we can have an outsized impact in terms of addressing climate. And also because we know that methane emissions, in terms of looking at the different sources, the largest single source of methane emissions is what comes from the whole oil and gas sector in terms of looking at emissions from the production through the distribution cycle. And so to start us off today, I first want to turn to Dr. Amanda Stout, who will talk a little bit about the science of methane and what this means in terms of impacts upon climate. And Amanda is the director of the Board on Atmospheric Sciences and Climate and the Polar Research Board at the National Academy of Sciences. And of course, the whole impact of looking at things like methane and what is happening with regard to climate. and that this is really important in terms of looking at the impact in terms of our polar regions and the huge impact there. So, and prior to joining the Board on Atmospheric Sciences and Climate, Amanda had spent several years as a senior climate scientist at the National Wildlife Federation, but she has done much in the way of research and modeling with regard to looking at climate and what this means in terms of climate science impacts in the Arctic and beyond. Amanda?
Thank you so much, and good afternoon to everyone. That is not my picture. and I venture to say that there are very few climate science talks that have started with a picture of Abraham Lincoln. Maybe this is the first. But for those of you who don't know, the National Academy of Sciences was founded by Abraham Lincoln in 1863. And President Lincoln had the foresight to know that our nation needed a source of independent and objective advice on matters relating to science, technology, engineering, and medicine. And that's just what this organization has been providing for over 150 years. Now, Abraham Lincoln might have had a lot of foresight about our nation's needs for science, but I doubt that he had foresight to expect that one of the most pressing issues of our time is climate change and what we're going to do about it. But the fact is that the National Academy of Sciences have published dozens of reports on climate science going back to the 1970s. In fact, one of the first reports we published is the famous Charney report, which did the first calculation of how much warming you might get from a doubling of carbon dioxide, and they got it pretty much right. We did a report in 2001 at the request of President George W. Bush, Climate Change Science, that laid out our understanding at the time. You may be familiar with America's Climate Choices that came out in 2010 and 2011 at request of Congress as well. And this broad body of work has helped us understand what we know about climate change. And drawing upon that work and about the work of all the scientists who contributed to it, we know that human activities are changing climate. Perhaps the most clear treatment of that is in this booklet that we published earlier this year. There's copies out on the table if you want it, Climate Change, Evidence and Causes. And we did this report together with our sister organization in the United Kingdom, the Royal Society. And it lays out, I think, really clearly the things that we know about climate science. So I'm going to just go through them pretty quickly. We know why carbon dioxide and other greenhouse gases like methane cause warming. We understand the physics of the greenhouse effect. We know that greenhouse gases are increasing in the atmosphere. CO2 today has increased by about 40% over the last 200 years. Methane has increased by about 150% over the last 200 years. And we know that these values are higher than at any time going back for the last 800,000 years based on our observations in ice cores. We also know that the planet has warmed by about 1.5 degrees Fahrenheit since 1900. And we know this because we have thousands of places around the planet where we are measuring the temperature. And then we have multiple different independent analyses of those temperature data that have all come to the same conclusion about the temperature record. We know that the planet is changing in other ways that are consistent with warming. We know that ice is decreasing, snow is decreasing, the heat content in the ocean is increasing, and our sea levels are increasing as well. And we know that more warming is expected as we continue to put carbon dioxide and other greenhouse gases into the atmosphere. These two maps show the amount of warming we might expect if our emissions continue on a business as usual trajectory, in which case we're looking at something on the order of 4.7 to 8.6 degree Fahrenheit warming by 2100. That's the right-hand map. But we also know on the flip side that reductions in emissions can limit this future warming. And you can see on the left-hand map that we could have significantly less warming if we were to take major reductions in emissions. Finally, we know that just a few degrees of warming is a cause for concern. Temperatures during the last ice age were just 5 to 7 degrees cooler than they are today. So the type of warming that we're talking about is significant. And we know that the warming we've already experienced is already causing widespread changes in regional and local temperature and precipitation. It's causing changes in weather extremes. We're seeing more frequent heavy rainfall events, more frequent heavy snowfall events, more frequent heat waves. And we know that there are already being seen impacts on human societies and the natural world. So there's the question, how can we limit future warming? And the answer to this question is at once deceptively easy and incredibly difficult. This is how it was put in this report by the National Research Council in 2010. The United States needs prompt and sustained strategies to reduce greenhouse gas emissions. All right, so if you're going to reduce your emissions, the first step would be to know what are your emissions. And indeed, the Environmental Protection Agency has been completing inventories of U.S. greenhouse gas emissions since 1990. And here's the pie chart of the gas emissions in 2012. And you can see that carbon dioxide is the largest one in this pie chart. And that is the main reason why most of our attention has focused on what we can do to limit carbon dioxide in the atmosphere. But you'll notice that there are a few other gases there too, methane and nitrous oxide. And these gases are important as well, and I think we're increasingly recognizing the importance of them. For one thing, these gases are much more potent than CO2. So if you look over 100 years, a single molecule of methane will have 28 times more warming than a single molecule of CO2. If you look over a shorter time period, like 20 years, a single molecule of methane will have something like 84 times as much warming as a single molecule of CO2. So methane packs a pretty big punch. These gases are also shorter lived than CO2. So we think of methane as a significant, short-lived climate pollutant, as was mentioned before. And here's one way to think about this. So this is a plot from the recent Intergovernmental Panel on Climate Change report that came out in 2013. The red line on the top shows basically they did an experiment where they said, let's do emissions for 1 year, and then let's track the temperature response to those emissions over several decades. So the red line on the top shows how the temperature responds to carbon dioxide, and you see that it has a long, sustained impact on the climate. Methane, which is in the orange, has a similar magnitude of impact in the near term after it's emitted over the first couple decades, but then it's rapidly removed from the atmosphere. So after about 50 years, the amount of warming from methane is negligible. You can see that there are a whole range of other short-lived climate pollutants that have other lifetimes and impacts as well. So what does this mean in terms of what we can do in terms of controls? Well, this report from the academies that came out in 2011 made the strong point that controls on carbon dioxide and on these short-lived climate pollutants affect different aspects of the climate. And this is how they put it, the effective mitigation of methane and black carbon and other short-lived climate pollutants is to trim the peak warming rather than to limit the long-term warming to which the Earth is subjected. If early action to mitigate methane emissions was done instead of action that could have reduced net cumulative carbon emissions, the long-term CO2 concentration would be increased. In fact, there was an analysis that came out just last year where they did this experiment in a model. So the top line shows the warming if we follow a business as usual trajectory for greenhouse gas emissions. The sort of greenish yellow line shows what would happen if you just reduce CO2. And you can see in the short term, up to 2075, that warming still increases pretty rapidly, but then eventually we start to level off. The orange line shows what would happen if you would have reduced the short-lived climate pollutants. And you can see that in the short term, over the next few decades, you can slow warming significantly more than you could if you were just dealing with CO2 emissions. And finally, if you look at the pinkish magenta line, you can see that if you were to do both the CO2 and the short-lived climate pollutants, you get the benefits both in the short term and in the long term. And you're able to reduce your CO2 levels and your warming overall in the long term more. There are several other reasons why you might want to think about doing something in the short term. We are already seeing impacts. So of course, anything that we can do to reduce the amount of greenhouse gases in the warming now should address those impacts. It will also be important in terms of slowing the rate of warming. And for things like ecosystems which are struggling to adapt, that rate is very important. It also could provide us some time to build resilience within our human systems, to adapt to the changes that are inevitable. And finally, there may be some other benefits in terms of health and agriculture from doing some of these actions to reduce methane emissions and other short-lived climate pollutants. All right, so what are these emissions of methane? Carol mentioned that there are many. And here's the EPA's inventory from 2012. Something like 40% of the emissions come from fossil fuel energy. And it's from a whole range of different points along the pathway from extracting the fossil fuels to production to distribution, even the pipelines that deliver gas to our homes. Much of that energy is lost in terms of leakage from the system and would have economic value if it were captured. And my colleagues on the panel will be talking in a lot more detail about the opportunities to do something about that methane, those methane emissions. It bears noting that there are some other significant sources of methane. One is from agriculture, and this is partly from the way that we manage our manure, and partly from what goes on in the guts of cows and sheep and pigs and that sort of thing. And there are efforts underway to try and address some of those emissions as well. And finally, waste is a large source of emissions, and that's largely the gas that outflows from landfills. And again, there are fairly low technology solutions to that problem, as well as many of these other problems. So one big takeaway in terms of methane emissions reductions is rather than trying to do a wholesale change in the way that we provide energy to our economy, you can do a number of relatively small, focused, low technology solutions to address part of the problem. And you can get a pretty bang for the buck out of technology that we already know how to apply. The other thing I want to point out about this is that it's actually really hard to do an inventory of methane. And there's quite a bit of debate about these numbers and what are the different sources. And that's an area of active research right now. And in fact, we at the National Academies had a whole workshop on that just last week. So I think with that, I'm going to turn it over to my panelists and just remind everyone that all of the reports from the National Academy of Sciences are free and available online, and you can find them and lots more at americasclimatechoices.org. Thank you.
So we will now turn to our next panelist, LG Holstein, who is the Senior Director for Strategic Planning at the Environmental Defense Fund in their Washington, D.C. office. LG brings a wealth of experience on the policy side. He has been in senior positions in government, including as well as in the private sector. And he has been in previous assignments at the Department of Energy, at NOAA, the White House. He's worked here on Capitol Hill, and he also has worked at the National Conference of State Legislatures. So he's sort of seen the policy side from a whole lot of different perspectives and angles. And he also has been involved in the private sector. And of course, at EDF, there is much work and commissioning of reports underway with regard to methane emissions and of course, as part of their overall climate agenda. And LG will be talking to us about some of that. LG.
Thank you very much, Carol. And Carol, thank you again for hosting this panel today. We hope by the time the panel is over with that we will this afternoon have convinced you that action on carbon pollution is tremendously important, but action on some of these short-lived climate forcers, climate pollutants such as methane, is equally important in order to, as Amanda beautifully described, affect not only the overall climate, but very importantly, the rate of change, which specifically, of course, goes to what we actually experience and the generation or us experience in the near term. And I tend to think of it also, Amanda, as buying the time that we need to come up with the solutions that will mean a cleaner environment and lower emissions, and avoiding that tipping point that we're all so familiar with and concerned about when it becomes impossible to turn the clock back, and we've launched into a new era of truly disastrous impacts on our planet, on our societies, and our economies. So let me pick up then where Amanda left off. Amanda, I don't want to steal your pen. Is that yours? No? I will steal it then. Let me pick up where Amanda left off and talk for a moment then about solutions to the methane problem. Now, we believe, again, I'm with Environmental Defense Fund, that one of the most important solutions is for the government to take action. And specifically, that means the Environmental Protection Agency using its existing authorities and the Bureau of Land Management. Now, David Doniger, in a few minutes, my colleague at NRDC, will be talking in greater detail about the EPA opportunity. But let me just capture the idea behind what we're looking for from the Bureau of Land Management. BLM, under federal law, is required to make public lands available for multiple use. So that does mean the mining of coal, and it does mean the exploration and production for natural gas and oil. And of course, that policy has been in place for many years. But they're also required, because these are public lands, to avoid waste and to avoid unnecessary pollution, and to undertake activities that, as technology changes, ensure that the public's resources are protected in the long term, and that the waste does not occur. Now, the waste has two implications when we're talking about public lands. One implication is the obvious one, which is when you have waste, such as the leakage of methane from natural gas operations on public lands, you get more pollution, more climate change, and faster climate change as Amanda has described. But the other dimension is that the public actually potentially loses out on royalties because those emissions go up into the air, excessive emissions that are beyond BLM's reach or beyond what BLM decides it's going to reach. And those resources are then lost in terms of doing the calculation of what you and I as co-owners and other members of the public as co-owners of these resources should recover in terms of the royalties. And so from our standpoint in the environmental movement, it's critically important for the government to take the lead in this area and demonstrate that they can use existing authorities and responsibilities that they have under key statutes in order to ensure that the natural gas revolution that's occurring does not end up worsening our environmental problems instead of potentially making them better than they would otherwise be. So we at EDF understood going back several years that the methane problem was a more serious one perhaps than many people had realized, but we also quickly discovered that there was not adequate information about the sources and of methane emissions and about opportunities for doing something about limiting those emissions. And so we've undertaken about 16 different scientific studies, and we've undertaken them with lots of interesting partners, oil and gas industry partners, universities, independent scientists. And the main point I want to convey is that every single one of those studies is going to be, or in the case of the several that have been completed, have been peer-reviewed. And so they will end up in scientific journals, and they will have gone through a very rigorous process of review. They will all be subject to the independent oversight by outside scientists. So we have no control over what the conclusions are, though we obviously have our own views about what the policy implications are, as I've just briefly described with respect to EPA and BLM. One of the most significant studies that I should say all the studies will be complete by the end of this year, but they won't all necessarily have been published by then. Again, that's not up to us, it's up to the peer reviewers and the professional journals, but let's just say going into 2015, you'll start seeing a flurry of these studies as they begin to make their way out through the scientific community. So this is one of the more noteworthy studies that we undertook. We commissioned ICF International, which many of you know is a well-known, widely respected company with lots of international experience, particularly in the oil and gas sector, and asked them to take a look at what the opportunities were for reducing methane emissions, and in particular help us take a look at what, and here of course is the key question, because if we're persuaded by Amanda that we should do something, and that the problem of methane emissions is serious and needs to be viewed together with what we call the "and" proposition, together with the longer-term problem of carbon emissions, then we have to say, okay, fine, but what's it going to cost, and will it derail the natural gas revolution that's occurring in America? So let me see if I can hit the right button here. Clearly not the right one. This one, yes. Always go to the forward arrow. So the first time I saw this slide, I wanted to run from the room, but let me assure you, you don't have to. And it doesn't matter if you can't read the small print, because the high concept here is going to be very straightforward. Those of you who picked up the handouts out on the outside table will have this slide. But basically what this slide does is take a look at the costs of addressing methane emissions across the natural gas supply chain, and tries to get a handle on the key technologies and the costs of doing something about methane emissions. So let me say a couple of things first, and then I will give you simultaneous United Nations translation of the slide itself. The most important thing to understand when we're talking about the existing infrastructure, about infrastructure that's leaking methane, is that although methane emissions will continue to rise in coming years if we don't do anything about it, because of the natural gas revolution that's underway in America, the vast majority of methane emissions in coming years will continue to come from the vast network of existing infrastructure that we already have in this country. So yes, the natural gas revolution will further increase those emissions, but we have a great deal of equipment already in the ground and business procedures already in place that we're suggesting need to be addressed. So in the small print, what you're seeing is a series of bars that represent different parts of the supply chain, different pieces of equipment, and so forth. The width of the bars refers to the amount of methane that is implicated by whatever particular bar it is. So that horizontal axis is billions of cubic feet of methane. And the bars, as they rise or as they go vertically, indicate a cost of doing something about the emissions that come from those particular types of activities and equipment. And so to simply capture the fundamental message of this slide, it is that the bars that you see in green represent steps that can be taken with respect to pieces of equipment. And I'll give you an example or two in a moment, but steps that can be taken that actually will result in a positive payback to the industry participant that undertakes those changes. And that happens simply because of the value of the resource itself. If we're no longer emitting it, but rather keeping it in the system, then that brings value back to the company. Whereas the blue bars, as you see them over on the right-hand side, indicate some cost going forward to the industry. But if you take basically all of these technologies, pieces of equipment, if you take all of these practices represented in this slide, what you end up with is a very important bottom line. And that bottom line is that we can knock off about 40% of these methane emissions that we are experiencing at a cost of less than 1 cent per 1,000 cubic feet of gas produced. Now, if we think of the price of natural gas now, and of course it's fluctuating, but over $4 per 1,000 cubic feet of gas, 1 cent per MCF of gas produced seems to us anyway like a reasonable price to pay, or to ask the industry to pay with respect to getting a handle on this problem and ensuring that the natural gas revolution really does redound to the benefit of our country. And of course, these are solutions that can be taken overseas and shared with lots of other countries that are wrestling with greenhouse gas pollution as well. The kinds of technologies or equipment that I'm describing are very mundane things. They're things like compressors, they're things like valves, they're things throughout the supply chain that we're all familiar with, but have been were put in at a time when people weren't, including us in the environmental community, weren't paying particular attention to methane. So for example, imagine a valve that was designed to operate based on the pressure of the natural gas in the line, and the valve actually opens and closes by emitting methane. And methane, I should say, is 97 or 98% of the volume of natural gas. So sometimes we use these terms methane and natural gas interchangeably. Let me then go to the next slide and Magically, there we go. So this is a map that you may also have. It's also out in the handouts. This is from a second study we did, because even though you just heard me say that these pieces of equipment are mundane in the sense that they're already out there in the supply chain, we wanted to know, well, who's out there making the equipment that doesn't leak? Who's out there making the compressors that are sealed? Who's out there making the seals that don't leak? And so we commissioned yet another company, Datu, which is very good at doing this kind of market survey work. And you can see here a representation of the number of companies around the country that are already engaged in this business. So we know that we have the manufacturing infrastructure necessary to develop and put into the field the technologies we need. Indeed, these companies are already making those technologies. And that, of course, begs the question, well, if indeed this is a problem, and if it's so inexpensive to do something about methane, and we have all these companies and workers out there benefiting from doing that, then why do we need EPA and why do we need BLM to do something to make sure that the industry actually uses these products? And part of the answer to that question is to tell you that there are leading members of this industry that are already moving forward and making commitments to do the right thing. But there's no reason why they should be put at some sort of competitive disadvantage or looking over their shoulders at maybe somewhat less responsible brethren who would choose not to spend even that penny per MCF or less on making these changes. It's a little bit like thinking about why it is that so many companies, or even some of us as individuals, don't make energy efficiency improvements to our factories or to our homes. And the answer often is because they have different priorities, or because maybe they don't even know about this as a problem. And that's a classic case of what's going on in the oil and gas industry in America right now. They are racing to tie up the shale properties from which all this new oil and gas can be produced. The exploration and production budgets of these companies are heavily dominated by acquiring these lands and beginning production, and very important for them, building the many thousands of miles of gathering lines and pipelines necessary to bring that new product to market. So what am I simply saying? That the problem that Amanda described and the solutions that I've talked about are not first in order of priority necessarily for some of these companies. And let's face it, some of these companies would prefer to have some of their other members in the industry take the lead on this, and while they continue with business as usual. Whereas we would like to accelerate the changeover in this industry in order to make sure that the natural gas revolution in this country ends up being a true winner. Thank you.
Now we're going to continue looking at what the possibilities for dealing with methane emissions are by hearing next from David Doniger, who is a policy director and senior attorney for the Climate and Clean Air Program for NRDC, the Natural Resources Defense Council. David has been involved in working on climate and clean air issues since 1978. So he's been involved in so many of the Clean Air Act legislation and regulatory issues, as well as climate issues, including looking at stratospheric ozone depletion, as well as the Clean Air Act amendments of 1990. And he also spent time during the Clinton administration at EPA as a senior counsel, and also at the Council on Environmental Quality, went back to NRDC, and has been heavily involved in a number of cases that now have gone to the Supreme Court, and working forward with regard to looking at how we resolve some of these climate issues. David?
Thanks very much, Carol. You make me sound older than most of the natural gas infrastructure, but younger than power plants. So, so NRDC comes to this problem with the perspective that how does this work, by the way? There we go. We have a portfolio of major sources of carbon pollution, of heat trapping pollution, and we need to act on all of these. In fact, we need to be aiming towards a clean energy future which is dominated by efficiency and renewable energy. But for a long time, we're going to be using fossil fuels, and especially for a long time, we'll be using natural gas, and it seems critical to us not to leak it away into the atmosphere. It's also critical to the efficacy of the Clean Power Plan, the power plant standards, to maximize the use of efficiency and renewables, but to the extent that gas is used, to have that delivery of the gas be as tight as it can be, so you don't undermine and erode the point of combustion advantage that gas has over coal by leaking stuff away on the way to the plants. Here's how we see the methane regulations that we believe are needed fitting in. The top of the list is the Clean Power Plan. If a 26% reduction is made by 2020, which is the EPA estimate of the impact of its interim standard, that would be about a 650 million ton reduction of CO2 in 2020 below 2005 levels. We've had significant progress on fuel efficiency and carbon emissions from new vehicles through 2 rounds of clean car and fuel economy standards, and 1 round and a second one underway for trucks, which would reduce emissions about 200 million tons of CO2 below expected levels by 2020. And the next biggest thing is the leakage of methane from the oil and gas sector. And as I'm going to explain, we think that somewhere around 130 million tons equivalent of CO2 can be reduced, maybe more than that, through a set of measures that are based on the studies, or based on the analysis that LG already laid out. And NRDC, Environmental Defense Fund, Sierra Club, the Clean Air Task Force, Earth Justice, a number of other organizations are working together to press the administration to make the decision to go forward with methane regulations as part of the strategy of getting to the target, the President's target of a 17% overall greenhouse gas reduction from the 2005 level by 2020, and as an important part of whatever the target would be for 2025 or 2030 in the coming round of treaty talks. So we've heard several different numbers used. We actually are using the potency estimates from the from the most recent IPCC report, 36 times more potent than CO2 per pound over a 100-year time frame, 87 times more potent over a 20-year time frame. The EPA estimates that there are 7.7 million metric tons of methane emitted from that system. We think it could be substantially more than that, actually. The 7.7 million tons would be equivalent to more than 260 million metric tons of CO2 equivalent. And with enhanced standards, we think this could be reduced by up to half, which, as I was saying earlier, would equate to about 230 million metric tons of CO2e each year. And it could be accomplished in about 5 years. And it could be bigger than this if the actual leakage is bigger, because then the measures I'm about to talk about would scoop up more methane and keep it out of the air. There were some initial standards set by EPA in 2012 for the burst of emissions that come at the At the end of the fracking process, the so-called completion emissions, I think of it as popping the top on a soda can, and there's this whoosh of emissions that are here today and gone in about 2 weeks. But it's a significant amount of VOCs and methane that escapes into community air and into the global atmosphere. And EPA's requirements for so-called green completions equipment, basically to mobile equipment that can separate the liquids and the gases and then recover the gases instead of leaking them away, is a very sound measure. Pays for itself. Very cheap if it costs anything at all. And I think it's just about fully in effect, and EPA is starting to pick up the benefit of it in the inventory. But it's only one measure at at the well pad. There's more to be done. Together, the organizations I mentioned, they're working together, have identified 5 categories of emission points, which to us make perfect sense for EPA to tackle going forward. Equipment leaks up and down the system. There's these pneumatic equipment that I think LG mentioned, compressors, liquids unloading, which is basically, these wells get a case of bronchitis and they need to have the liquid removed from them in order to breathe freely and continue to pump their methane, and that can be done in ways that releases a lot of methane or ways it does not. And then the 4th item there is referring to the completion emissions of drilling, of fracking wells whose primary purpose is said to be oil recovery, but which contain a lot of gas and are not covered by the regulations I was mentioning before. So if we extend the green completion requirements to those gassy oil wells, that would be another major way to pick up methane reductions. And you can see again the numbers that we're talking about. Now, EPA and the administration have published a methane strategy. The administration published a methane strategy in March. It promises decisions this fall, sort of a triad of alternatives. One is to rely on continued voluntary programs. I hope that was just, to fill out the trio. I would be shocked and very upset if EPA opts for a continued voluntary approach for the reasons that LG mentioned. Good guys in the industry, leaders in the industry do the right thing, but not everybody does the right thing. And the whole point of having standards is to level the playing field for the industry, but also to capture the emissions that are left behind by the laggards. So the methane strategy also points to 2 routes that could be chosen under the Clean Air Act. One is to use, again, the route which was chosen for the completion emissions, the regulation of VOCs. In situations where a mixed stream of VOCs and methane are emitted together, a VOC control can amount to the same thing and capture both the methane and the VOCs. That's fine when the stream contains both VOCs and methane. But as you move farther down the system, especially you get to the processing plants, the whole point of which is to separate out everything but the methane and ship methane, or 97% methane, down the pipeline system further, you end up with no VOCs or virtually no VOCs in the stream. And a VOC-based regulatory system sort of stops there. The leakage continues, but it's all methane. So the scope of the VOC rules does not match the scope of the leakage problem. Another issue when dealing with existing sources is that the VOC regime can be applied only in the areas that don't attain the standards for ozone smog, which is what VOC, which is the reason VOCs are regulated. The oil and gas system has areas which operates in areas which do violate the ozone standard, but most of the system and most of the leakage are outside those areas. So the VOC authorities don't operate outside those zones. We advocate that EPA use Section 111B, as in boy, and D, as in dog, the same provisions which are being applied to the power plant regulations, because they apply to the emission of, in this case, methane, irrespective of where your sources are located, irrespective of whether they're in smog areas or not. Those methane regulations under 111D would also apply to any of the equipment that leaks methane, irrespective of whether it's still leaking volatile organic chemicals. So those two regulatory paths have a very different yield in terms of how effective they would be. And we estimate that you get 8 to 10 times as much methane captured by dealing with this problem directly under the 111 authorities than you would if you go at it through the surrogate of VOCs. The actual regulatory steps are almost the same. EPA writes a guidance, states have to write plans for the existing sources. EPA writes standards that apply directly for the new sources. All the procedures are essentially the same. And the technology tests are more or less the same. The economic tests are more or less the same. But scope is different, and scope matters here. So to sum up, the direct methane approach is, to us, the 8 to 10 times more effective approach than the surrogate of regulating smog-forming compounds. Much more effective, even more than that, compared to voluntary programs. These approaches can be built on previous EPA standards. There's plenty of examples of leak detection and repair, plenty of other standards that address this kind of equipment. None of this is rocket science. None of this even involves the kind of structural issues that are involved in the power plant plan. It's much simpler than the power plant plan. The Clean Air Act provides the authority. As I said, direct regulation, if you assume that the GWP is 25 or 28, you're talking about almost 100 million metric tons. If it's 36, you're talking 130 million metric tons. And if the leakage rates are actually more than that, it could be a whole lot more than either of those numbers. These measures are highly cost effective. They can be done quickly. I mentioned compliance and implementation is straightforward. It's not, doesn't have the complexities of the Clean Power Plan. And it seems like falling off a log to us in terms of a simple, straightforward decision that EPA should make, that the administration should make, and that, frankly, would be quite straightforward for the industries involved to comply with. And we hope that's what goes forward. Thank you.
There's also been a lot of work going on over at the World Resources Institute with regard to looking at methane emissions and the power plant standards. And to hear about that work, we will now turn to Michael Obeter, who is a Senior Associate for Energy and Climate at WRI.
Thanks, Carol, and thanks to all of you guys for coming here. I will try to keep my presentation brief because following after Amanda, LG, and David means that there's not much left to say on this issue. So I'm going to start my presentation with a quick statistic, which I think is actually pretty interesting and helps put the methane emissions question in context. Methane emissions just from oil and natural gas development in the U.S. are more than the direct and indirect greenhouse gas emissions from U.S. steel, iron, and aluminum manufacturing combined. And that's just using a 100-year equivalent that Amanda talked about. In a shorter time frame of 20 years, then methane from oil and natural gas development is actually a much bigger problem than those three pretty big industries, which is why we need to get this right. The EIA projects that natural gas production is going to increase by about 50% between now and 2040 has already increased by about 50% just in the past 6 or 7 years. So from a climate, air, and water standpoint, it's pretty critical that we get natural gas development right and then we start acting on it very soon. We don't have the time to take a wait-and-see approach. The good news is that we know how to address these issues, and this gets to a lot of what LG talked about. Studies from NRDC, the ICF and EDF study that LG referred to, a paper we put out last year at WRI, as well as EPA's Natural Gas Star program, all demonstrate that there are many cost-effective technologies currently available that can get at the large and small sources of methane in the oil and natural gas field. I should also point out the Center for Sustainable Shale Development, which is a consortium of companies and NGOs, including EDF, that's active in Pennsylvania, which is working to put some of these best practices into use in everyday operations. And not to take nothing away from the success of this group, which I think is great, but voluntary actions like these, as David mentioned, are not going to be sufficient to address the scope of the problem that is out there today. Before going forward, I just want to say a very quick word on the issue of flaring, and because it seems to be a hot button issue, especially in a lot of oil-producing states. And just to clear up any misconceptions about flaring as a way to reduce methane emissions, it certainly is an option for reducing methane emissions, but it should be viewed as a stopgap measure and not a solution. From a climate perspective, flaring can reduce emissions of methane by about 98%, increasing CO2, of course, because you're burning natural gas. But incomplete combustion during the flaring process means that you've got potentially significant emissions of methane, carbon monoxide, hazardous air pollutants, and volatile organic compounds, all of which are not nice things to have around. We know that where flaring occurs, it occurs primarily at oil wells that have a lot of natural gas, but there's not enough infrastructure there to bring that natural gas to market. Thankfully, this is a problem that can be solved with the right incentives. Congress and the states can help incentivize that infrastructure to put flared gas to more constructive use. So now, getting back to where the emissions come from in the oil and natural gas process. LG's organization, EDF, is putting together a number of studies that he mentioned, which will help shed a lot of light on this issue, because right now there is a pretty large gap in our knowledge base, simply because it's really difficult to track and to measure methane emissions. They're invisible. And loss of methane, loss of natural gas is too often built into the tariff structure of companies in this industry. So it's sort of a pass-through cost. They essentially just write it off. But as this graphic illustrates, there are emissions coming from every stage in the natural gas life cycle. This data comes from EPA's greenhouse gas inventory, and it's tough to see the fine print, but to sum up what's happening beneath these pictures is a list of studies that have come out in the past 5 years or so, almost all of which have indicated that the scale of methane emissions is actually greater and potentially much, much greater than EPA currently estimates in its inventory. The good news is, as I mentioned and others have mentioned, that we do know a lot about how to get at these emissions. And to give you just a brief overview of three options from different aspects of the life cycle, and hopefully not bore you too much and not get into too much technical detail. Just go through a few of those right now as representative examples. First are pneumatic devices, which LG covered a little bit. These are devices that regulate various components of the natural gas that flow through them: temperature, pressure, flow rate. And as LG mentioned, they are powered by natural gas. And as the course of normal operations, they bleed potentially significant amounts of natural gas into the atmosphere. They're about 1/3 of all methane emissions in the production sector. And we know that existing equipment that's in place now, as has been mentioned, will be a major source of emissions for years to come. But the good news is that we can retrofit or replace these high bleed pneumatic devices with equivalent devices that do the same thing, but with much less impact on the climate. There are low bleed and no bleed equivalents that can put a big dent in these emissions. No bleed pneumatic devices are an option when there is access to grid electricity. But even if there is no grid electricity available, retrofitting high bleed pneumatics with low bleed equivalents does make sense and is a way to reduce methane emissions and an investment that pays for itself in typically 3 years or less. Next, compressors, which do what they sound like. They compress, they increase pressure at the all the way from the production stage through the transmission and distribution. Big compressors called centrifugal compressors vent or leak a lot of methane through seals. A lot of the existing compressors have what's called wet seals. They use oil to try to keep methane from escaping into the atmosphere. The problem is that this oil, when it absorbs too much natural gas, it loses its effectiveness, and eventually a lot of natural gas is emitted into the atmosphere. So there are two options available for dealing with these wet seal compressors. You might expect one of them is dry seal compressors. They don't use oil, they emit a lot less methane. The other is to install equipment that can capture and reroute gas back into the processing plant. This is gas that would otherwise be vented, flared, leaked. And both of these options are cost effective. They've been proven to pay for themselves in 3 years or less. The gas capture systems tend to be a little bit more cost effective, and they can reduce emissions by up to 85% or more. Lastly, talk about pipeline venting along the transmission pipelines. When pipeline operators need to perform maintenance on their pipeline, the first thing they need to do is reduce the pressure in that pipeline. This is for safety reasons. You don't want your maintenance people blown up. That makes sense. So what they do is they essentially, there's two ways to reduce the pipeline pressure. You can just bleed a lot of it, vent it into the atmosphere. That's one way of doing it. Or you can just sort of push it through the pipeline section in question to the next part of the pipeline. Reduces the pressure and also reduces the amount of natural gas that would then be emitted into the atmosphere. For planned maintenance, when folks can plan ahead, portable compressors can push about 90% of the natural gas in a section of pipeline down into that next section. 90% reductions of methane is pretty good, and this is not a very expensive measure. For emergency repairs, when you don't have the time to secure a portable compressor, you can use inline compressors that are less effective but can still reduce the amount of methane that gets vented into the atmosphere by about 50%. And since we are currently in the Russell Senate office building, figured I would close with some opportunities for Congress. David talked about what EPA is doing, has done, and potentially will do on methane emissions. They are soliciting input right now on a number of major sources across oil and natural gas systems. And it remains to be seen whether, when, and how strong any regulations are that come out of this process. So with that in mind, there's a few things that Congress can do. First, there's a lot of research and development that gets done at the Department of Energy, and targeted R&D in this industry can help bring down costs of emissions measurement and control technologies, some of which Brent is going to talk about right after this. As I mentioned, a lot of these emissions control technologies are cost effective right now, but there are opportunity costs. As LG mentioned, these are investments that are made in emissions control technologies that would otherwise be made in drilling the next well or building the next pipeline. So bringing down the cost of emissions control technologies makes these investments even more attractive to industry. If EPA does not put out extremely ambitious standards for all of the segments of the life cycle they're looking at, or even if they do, there's still going to be some gaps. There's still going to be emissions that are not going to be covered by EPA, and those are gaps that can be filled with legislation. And lastly, there's always the tax code. Everybody wants to talk about how to use the tax code better. Well, one way is to incentivize the purchase and greater implementation of these emissions control technologies. And I will end there.
So it's always important to talk about, as we look at issues, at problems, and also we really need to think about solutions. And now we want to hear from somebody from the private sector who is part of thinking about how we deal with this important area of emissions measurement, the technologies needed to, as we've already heard, in terms of basically controlling these emissions, what's really available, and a company that is actively engaged in pursuing all of this. So to talk about his company's perspective and how some of the issues are being seen by them is Brent Lammert, who is Vice President for Sales and for Test Equipment with FLIR Systems. Brent has been with FLIR for about 17 years, so he brings a wealth of knowledge and experience to this whole area. Brent?
Thank you. And thank you all for being here today. It's wonderful to see a packed room, that there's this much interest in methane and helping our environment. I'm very pleased to see that. Thank you to EESI for the invitation to be a part of this panel and part of this conference. We appreciate that as well. With me today, I have two other gentlemen from FLIR, Tom Scanlon and Paul Serapusco. They were both instrumental in the early development of our optical gas finder, optical gas imaging business. And Tom brings a global perspective, is just back from Dubai and a conference on flares. So that's very topical. And Paul is in charge of our continuous monitoring cameras. And those are used in several new applications for optical gas imaging. So both of them will be available during the Q&A. Now, one thing I'd like to just ask, has anyone ever seen a methane leak? It's colorless, it's odorless, so it's difficult to see. Have you seen an optical gas imaging camera? Many of you have. A few have not. So I want to start off just with some video of what methane looks like to an optical gas imaging camera. And we can see large leaks, we can see small leaks. Importantly, we can also see the source of the leak, and this is important in being able to determine how to make the repairs and be able to make those repairs more quickly and often more cost effectively. A few of the videos may make you think twice about using your cell phone while you're filling up your vehicle as well. So this is just a small portion of the videos that our customers, our trainers, our salespeople see on an everyday basis. And at the end of the talk, we actually have a gas finder here with us. We'll allow you to actually see how it works. I did not bring the CO2 camera. We do have one of those, and we would see the hot air in the room. One of the things that optical gas imaging as a technology for LDAR does extremely well is it finds the big leaks fast. Yes, we can see small leaks, very, very small leaks, but we find the big leaks fast. And that's important because when we look at the sources, it's a small number of leaks that are the majority of the volume that's leaked. This is a recent slide presented in October from the National Academy of Sciences. And in the slide, just action at 10 to 20% of well pads would reduce emissions by 60%. That's incredible. So what we're trying to do is find those really big leaks, right? The super emitters, as we refer to them as well. And when a customer first starts using an infrared camera, they start playing around with it, learning how to operate, what each button does. This happened to be one of our customers the very first time they picked up and turned on the camera. They walked out the door and they started to look around. And what I want you to notice is that's outside the fence line of this plant. That's from an underground leak from a 36-inch pipe feeding into that plant. It would not be on anyone's list to inspect. And under a traditional LDAR program, you would not find that leak. But with an optical gas imaging camera and looking around while you're at your facility, you find the big leaks. You find them quickly, and you can find them at a distance. You also notice that there's a safety implication here too, right? That brings us to our next point. We are trying to reduce methane emissions for the effect that has on the environment, but it also has an implication for safe operations and safety for the general public. So that last video was outside the fence line. If someone is leaving the plant and believes that they're away from any dangerous atmosphere, what happens at that moment if there's a spark, an ignition, or someone lights a cigarette? That could be an incredibly dangerous situation. Normally, people rely on other instruments to find out what the atmosphere is around them. In this case, you see a TVA, a toxic vapor analyzer, and the tip of the wand there, and in this video, he can't find the leak. We can see it with the camera, and I'm going to turn on what we call high sensitivity mode, where in this digital filter, you can see exactly where the leak is. But the TVA didn't find it. It's incredibly powerful what optical gas imaging can do in the operations of a plant in being able to see, measure, and be able to move forward and make repairs. Now, it is something that when you find those large leaks, it's very profitable to fix them. That's something that was addressed earlier this morning. But we've had some end users present at conferences for us, and I'd like to show you some of the videos that they have in the next slide and some of the numbers that they've talked about with how much does it save when you find these leaks. A conference that we've hosted is called Petrotherm, and you see a couple of large leaks. Some of our customers have referred to methane or natural gas as $12 gas, since the BTU value is more expensive than gasoline. But we're not talking tens of thousands of dollars for a single leak, or $100,000. Often we're talking $500,000, $1 million of payback. The payback for the equipment and the repairs is incredibly rapid. I do want to take a minute to talk about regulation. That was one of the things as we prepared for today was, what does industry need from our regulators? What do we need? And I wanted to take a look at kind of a progression here. And by AWP, what I'm talking about is Method 21 and the alternative work practice, if you're familiar with that. And Method 21 and then the AWP was intended to actually allow the use of more technologies to be able to reduce emissions. Unfortunately, there was some language in there that required, if you used optical gas imaging, to actually once a year you had to use a TVA. So many operators will just invest in one technology and training for their employees in one technology rather than investing in both. So it actually reduced the use of optical gas imaging. Quad O addressed some concerns, but I'd like to highlight what's being done in Colorado right now. And this is a wonderful case study that's being looked at around the world as a way to have both industry and the regulators work together. And three key things that their legislation addresses is, what can I use? What tools am I allowed to use on my site? Well, I can use either a TVA, I can use OGI, but I don't have to use both. Next, they define the frequency of the inspection. So depending on the potential of the leak for that tank or other device, you have to inspect monthly, quarterly, or annually, so they know how often they need to. And then maybe most importantly, and this is something that was not addressed in Method 21, in the language there, you're given time to repair the leaks that you find. In Method 21, if you see a leak, you have to report it, right? And once you report it, there's a potential fine. So do you want to see the leak? Do you want to find that 36-inch pipe that's underground leaking that's not on anyone's inspection? What Colorado has done is they have made it so that you want to find all of the leaks. Yes, you report them, and yes, you make the repairs. And there's not a penalty as long as you repair them in the time frame and the schedule that you should. That's very common sense. That's very logical. And it's something where industry was partnered together with the state to come up with regulation that made sense and is doing a lot of good. For our products, we've been investing in this technology for a very, very long time. And it's something in the DATSU report, several of those bubbles on the maps were FLIR locations where we make the sensor and other key components for the gas finder at facilities around the US. Our Gen 2 added what we call a high sensitivity mode, a digital image enhancement that allows us to see gas far more effectively than before. And then in the Gen 3, an entire series of gas finders where we're able to put the reporting and the recording on board the camera, as well as we launched several new sensors to be able to see other types of gases. So while we're talking about methane here, that series of cameras can also see VOCs. We also have a series that see global warming potential gases like SF6 that are 23,000 times more powerful than CO2 and is used as an insulating gas in utility industry. We have a camera that sees carbon monoxide. It's used in the steel industry mainly for safety to see where there's leaks on the input to the blast furnace, something that unfortunately there has been several fatalities around the world, and using this technology is helping to reduce that risk. We have cameras that see various refrigerants, and then our latest innovation is one that sees CO2. And we're using that at several different places, including in the oil and gas industry, for enhanced oil recovery, or EOR, where carbon dioxide is injected into the well. And we're just going in and we're looking for leaks within the compressor system. So it's very similar to the equipment we inspect for natural gas. Other products that have been launched this year that are significant is a multi-sensor solution, as well as high resolution, and then a new OEM module. And that module allows us to put together solutions with partners that have never been done before in this industry. So we can put them into explosion-proof housings and monitor continuously, 24/7, looking for leaks, or into custom enclosures and even into airborne platforms to go onto UAVs or aircraft to be able to inspect very large areas and inspect pipelines. So thank you very much for your time today. We're going to switch over to a live demonstration with the camera in just a second, but I just want to leave you with, we find the big leaks fast, and we're looking for those super emitters. Thank you. So Paul, will you grab the camera, and we're going to just switch from the PowerPoint. If anyone was interested in how big, complex, how hard is this to carry into the field, you'll see that this camera is shaped like a camcorder. It operates on a battery, and will operate for several hours on a battery. It is a calibrated instrument in that it measures temperature, so we can see what everyone's temperature is. And Paul has a source for us. You see the gas? Yes. So that's just a tiny amount of butane that we're seeing. It's actually drifting down, Paul. Yeah. So thank you very much.
Wow, thank you. That was all very sobering and should put sort of all of this in context in terms of what we've heard. So why don't we open it up for any questions or comments any of you have? And if you would just identify yourself, please, when you ask your question. Okay, Curtis? Okay.
Hi, my name is...
Yes, if you could go to the microphone, that'd be great.
My name is Curtis Moore. I edit and publish something called the Health and Clean Air newsletter. For a number of years, I worked here in the United States Senate, and I take it that nobody seems to be aware of the fact that every holder of a permit to treat, store, or dispose of hazardous waste, and the theory behind it was that everybody who generates any waste at all, whether it's air pollution or water pollution, is required annually to certify that it is minimizing its waste stream. I don't know if any of you have ever bothered to look at those certifications to see whether they're true or not, but they would certainly apply to oil and gas pumping stations. I just wanted to make that recommendation to you. I've been involved in global warming for quite some time, and I'm glad to see that some attention is finally being paid to a specific source of a global, long-lasting, I coined that term, SLCP or whatever it's called, but I just refer to them now as short-lived global warming pollutants, air pollutants. You're only focusing on methane emissions from oil and gas operations. You're not focusing on, you don't seem to have any program for other sources of methane, even though they're easily controllable, or black carbon, which is the second most powerful cause of global warming, and it has a lifetime of only 5 to 10 days as opposed to 100 to 1,000 years for carbon dioxide. Are any of you considering in your organizations actual regulatory programs to address all pollutants that are short-lived that cause global warming? They constitute a majority or a near majority of all current global warming.
Well, I'll let other panelists also speak, but I just wanted to say for this briefing, we really wanted to narrow the focus. We thought that it was really important to look at this particular issue, just as we also indicated that there are a lot of other sources of methane that also need to be dealt with. And EESI has also done some past briefings looking at the whole group of short-lived climate pollutants because we think that they all need to be addressed. So I would bet that people on our panel are looking at all of those. But anyway, who wants to? LG, do you want to say something? And then Michael and David.
Well, I want to say something first about Curtis, because for those who don't know, he was a longtime friend of the environment here on Capitol Hill.
Well, he still is a long-time friend, right?
And should be acknowledged. So, Curtis, thanks for coming today. And I'm going to feel a little bit sheepish even being up here on the panel when you probably should be. But I'll say that at Environmental Defense Fund, we've actually been looking at some subsectors within agriculture, particularly rice cultivation. And I won't elaborate on that now for the reason Carol said, but we are concerned about it. Maybe I'll defer to David on the question of regulatory responses, but we are looking at ways in which you can cultivate rice without allowing the production of methane that occurs if you leave the remainder sitting in these flooded rice paddies for extended periods of time. And you can have a dramatic change in the methane releases if you undertake more careful approaches to the water management in rice cultivation.
We're working on HFCs. We're working on this source of methane. We're working on other sources of carbon. It's important to do as much as we can, but we're trying to chew on some of the biggest bites first, and ones where there's a clear regulatory path. So, Curtis, love to hear more about pathways on black carbon and other opportunities you see. But let's use the rest of this one on this opportunity.
Great. And Michael, did you want to add anything? Okay, terrific. And Curtis will have a book coming out in the spring that we should all be eagerly awaiting. So, other questions or comments? Okay, over here.
Hi, I'm Nathan Shapiro. I'm from Congresswoman Rosa DeLaurio's office. So far, oil and gas explorations, at least in shale, is rather in its infancy, and it's largely has been heavily influenced by the states. I mean, just look at what's happening in New York. Is there a concern that if federal agencies such as the EPA or the Bureau of Land Management try to get heavily involved and try to push regulations like you've been suggesting, that there will be pushback?
Sure. I mean, I think no matter what EPA does on any pollutant from any sector, there's going to be pushback from some states.
Gets pushback.
Yeah, I think, go ahead. I was just going to say, I think there's also been a lot of concern because as issues have arisen across a lot of states, that there has been concern about not as much state action moving forward with regard to addressing methane, as there undoubtedly, given the presentations, there has not been the kind of response from states that should be warranted, and it is a problem across the whole infrastructure, as we've heard. So go ahead, Michael.
So actually, I think states have taken the lead on this issue, although they haven't done nearly enough. The regulations in 2012 from EPA that David mentioned were modeled largely on successful regulations in Colorado and Wyoming. And then we talked about what Colorado is doing right now, requiring leak detection and repair on a regular schedule depending on the size of the facility. And I think that can also serve as a model for what EPA is doing. I think ultimately, national regulations from EPA that address methane emissions directly across all segments of the supply chain are going to be necessary, but I think there's a lot that states can do in the meantime to sort of prod EPA to lay the groundwork, to demonstrate that these are cost-effective measures, that they can work with industry and bring industry on board. And as it happens, I'm actually working on a paper right now that's going to come out in about a month or so, looking at state approaches to reduce methane emissions from all of these different aspects of natural gas systems.
I'd just add that some of the most productive and the biggest accomplishments under the Clean Air Act have come in situations where there have been a leadership state or a set of leadership states, and they demonstrate what can be done, and then EPA is able to nationalize the result. And the clean car examples, where California's been the lead for so many years, along with some of the eastern states, including Connecticut, I think, have resulted in those clean car and fuel economy national standards. It wouldn't have been leveraged. It wouldn't have happened without the state leadership. But at the same time, there were states who were obviously not willing to join the club and even opposed to the federal government doing that step of taking it national. I think Colorado is the new California with respect to its leadership on natural gas, some other states too. And there's an opportunity to do the same kind of leveraging here with the support of many, many states, even states that are not sure they want to see the shale gas resource opened up. They still want to be sure that to the extent it is in their states or in other states that they don't, methane isn't leaked away, causing global warming, more global warming for us all. So there's a broad coalition of support for this among the leadership states, and it's not your father's Oldsmobile of leadership states. It includes some interesting new ones like Colorado.
Mike McCracken from the Climate Institute. This is mainly, I think, for David and LG or something else. So with EPA, you have the endangerment finding driving the science and driving action. If you go to the Bureau of Land Management, however, you're seeing very different kinds of things. At least for the Powder River Basin coal, where I've specifically looked at the environmental impact statement done in 2004, it essentially dismisses IPCC. It says there's no specific findings that are of any use at all. It was taken to court, and the judges ruled, well, at least they addressed it. I mean, it was in section 4, which was maybe 300 or 400 pages long. They had 4 pages that basically said it wasn't useful. If you look at the approval that I guess went out yesterday from one of them, I don't know if it was BLM, for the action in Alaska, and you look at that environmental impact statement, its statements were, as I recall, I don't have the words exactly, but there's nothing specific we can identify, and in any case, the emission is minuscule, so we're going to sort of totally ignore the climate change effects. They have a whole section where they talk about climate change is going to occur and what that might do to operations and everything. They don't say why climate change is occurring there, but they have this section that just doesn't do it. What in the world are you, where do you get hope that BLM is going to actually seriously address this issue? Because I don't see any indication that they are.
Okay.
I can be so blunt as to say that.
Who can talk about hope? Okay.
So let me just make one point. I'm not an expert on the BLM rules. I'm going to defer to LG on this, but I believe it's the case that if EPA establishes these methane regulations limits that I'm talking about, they will apply not only on the private lands, but they'll also apply on the BLM lands. So you have an opportunity for some sort of matrix where BLM can add value to aspects of this that the EPA leakage rules wouldn't address.
I can't speak to whether BLM will warmly embrace this idea or if indeed they will, how long it might take. But we are from the environmental community after all, and we're overflowing with the audacity of hope. But I would say that there are, I think, requirements in law, as I said during my remarks, on which we can hang our hats both from a policy and a legal standpoint, and they have to do with the obligations I mentioned that BLM has as the steward of these public lands. And those twin obligations are to reduce waste or minimize waste, number one, and number two, to prevent unnecessary pollution. And we would certainly argue that that pollution reference is not limited to the spillage of chemicals at well sites any more than pollution from coal mines would be limited to non-air releases of chemicals. So we do think that there is a strong basis for making the argument, and that ultimately, and this I presume will be, and I'm going out on a bit of a limb here, but the President's request and or stated intention, which David talked about, to this fall announce a package of responses, and we hope they're not purely voluntary. We would assume that BLM regulations would certainly be on the table for that discussion, and so that's the case we're making. If we don't achieve that goal, let's come back and talk about it again on January 1st.
Because was this involved in terms of the president's roadmap with regard to, in terms of looking at the methane strategy? In terms of talking about BLM? I thought that BLM was part of that. Okay. We have time for a couple other questions or comments. I think there are lots of things that need to be followed up here, just like in terms of what Dr. McCracken just raised. And I must say that, you have a question? Sure, go right ahead.
Hi, I'm Molly Gilligan from IUCN. I know most of the panelists here are U.S.-based, but I was wondering if any of you can expand upon the global aspects of this issues, maybe if any of your work or research is being applied to global solutions for this global problem. Thank you.
Well, I just mentioned that we have a substantial operation in China, and there's the Chinese are interested in seeing if they can produce more natural gas, and we're interested in providing them information on how, if they do that, they can do it with the lowest impact on environmental impact, including the lowest losses of methane. So, and then we're also working to make sure they know of the problems that we found in this country with respect to the fracking operations and what you have to do it more or less well or more or less poorly. So, yeah, we're trying to be a force to educate and get a better result in China than you might have otherwise. That's the main area outside the country where we're active.
As we complete the 16 studies I referenced, we will take those results and try to disseminate them more broadly. And a specific focus for us is Europe for next year. And hopefully we'll be able to go to countries in Europe and make the case that the United States government has demonstrated some leadership on this issue, and that United States industry has proven that there are products and technologies rapidly improving, as you saw in the FLIR presentation, that can actually bring about a rapid reduction in these methane emissions. And I think perhaps in the discussions that we had, there was one term I noticed that we didn't define, even though I and others used it, which is LDAR, and that acronym refers to leak detection and repair, what FLIR's presentation was all about. And obviously, figuring out where in the world this methane is coming from, our studies look at that at a fairly high level. FLIR and companies with those kinds of technologies enable their customers to pinpoint in industrial operations the precise locations of these emissions. So I do think that there are numerous technologies and techniques that we can take overseas, and FLIR, of course, already is doing that as part of its everyday business activities. We hope to come on their heels with a strong policy case and scientific case that this kind of action is urgently needed.
I actually just wanted to ask Brent or someone from FLIR to comment about that, because it just seems to me that one of the most powerful tools is, in terms of what you were showing, that in terms of really making the case and in terms of people being able to see what is really being dealt with. So are you seeing an uptick in the international market and interest?
I might defer to my boss, who's responsible for the rest of the world, rather than myself. Okay. We are seeing gas finder sales around the world. I will say in Europe, they're ahead of us when it comes to offshore, looking for leaks and methane than we are here in the U.S. Mm-hmm. I think around the world, people are looking at Colorado as an example to study and see if there's pieces or all of that legislation should be applied in their countries is something that we're seeing. And as far as the comment about the power of being able to see the gas, we all understand what's happening. We see the numbers in the charts, but we all have a very different reaction when we can see it with our own eyes. It's a visceral reaction. We see that with producers, where the personnel that are responsible for the LDAR applications, where they take a lot of pride in the work that they're doing for their company, for their environment, and when they go home and talk to their families and to their children, they take a lot of pride in what they do with their work every day.
Did you want to add anything?
On Tuesday, in the way of answering the question on international impact, I was in Abu Dhabi. And I was there at a conference that was totally dedicated to flare management. And I want to leave you with just a couple thoughts about the impact of what we do here and how it can impact what's going on around the world with regard to emission control. And the first thought I want to leave you with is the power of what happens here, both in the regulatory community and with our multinational corporations. In the regulatory community, the EPA has endorsed and adopted this product, and of course the most significant endorsement is they bought it and they're using it. And when you go overseas and you get questions about who's using the camera, even though not every nation in the world admires the United States or might even have some issues with the United States, there is broad respect for this nation as an incubator of technology. So when the EPA adopts our technology, everybody listens. And when Mobil, Exxon, or Shell, or BP buys our cameras because they work or because they're getting a little bit of a regulatory push, everyone around the world listens. So an important point to leave you with based on what I saw on Tuesday. And I think the other factor that I was really surprised was the extent to which the OPEC nations are citing data from the World Bank and other locations, other information sources on where they stack up with the rest of the world. And they're interested in it. They're not turning a blind eye, and I heard more than one presenter when I was in that conference talk about their kids coming home and asking them, "Daddy, what are you doing to improve the world emissions issues?" They're not using emissions, they're talking about pollution. But it's this information on how they stack up with the rest of the world, and I saw more than 3 presentations where they were referencing how they stood with regard to emissions compared with Russia and other states around or other nations around the world. So in the way of perhaps leaving a little bit of hope out there, I was very impressed with what I saw, and what we do here can have a big impact on what happens around the world.
Thank you. Well, and that just makes the case for doing something, right? And I think that's terrific in terms of looking at the whole role of the whole technology development side that your company, other companies have played in terms of looking at issues like this and finding solutions so that we can better deal with things. Because as we've heard from all of our speakers in terms of looking at climate, other environmental issues, economics, and obviously public safety. So I want to thank all of our panel very, very much. And I appreciate all of you staying since we have gone past our appointed hour, but thank you all very, very much. And I'm sure that our speakers can take a little bit of time if you have other questions that you want to follow up with. So thank you. We hope to do more topics right along this whole area of short-lived climate pollutants. Thank you so much.